Good morning, everyone. So the event will start at 9 o'clock a.m. Philippine time. That's in 14 minutes. Thank you. Good morning once again to everyone. Thank you for logging in early. The event will start at exactly 10 minutes, and that's 9 a.m. Philippine time. So just to run through some of the reminders for the audience, um, kindly rename your name here to the first and last name and affiliation. And by default, kindly mute your microphone. And we'll be having a Q&A allotted for 5 minutes after each presentation. But don't worry, there will be more time during the open forum after all the presentations. For those in the meeting, please type your questions in the chat box. And for those watching the live stream, please comment your questions in the comment section. Kindly include your name and affiliation when you send in your questions, and we'll try our best to accommodate all of them. So all of the questions through Zoom's chat box will only be directed to the host and co-hosts of the meeting. And just to inform everyone, the meeting is being recorded and live streamed. So in case you want to go back to some of the topics, it will stay up on the UP Diliman IESM page and the Stamina First Space Facebook page. Thank you.
Kasunugin dito? Ito, more? Ano ka?
Hello, good morning again. So it's now 8:55 here in Philippine time. The event will start in 5 minutes. For those who just came in, we would just like to share the following reminders. By default, kindly mute your microphone. We'll be allotting 5 minutes after each presentation for Q&A. But not to worry, there will be more time during the open forum after all the presentations are done. And for those in the meeting, please type in your questions in the chat box. And for those joining us in the live stream, please type in your comments in the comment section. And kindly include your name and affiliation when you send in your questions, and we will try our best to accommodate all of them. So the questions through Zoom's chat box will only be directed to the host and co-hosts of the meeting. And just to inform everyone again, the meeting is being recorded and live streamed. Thank you.
Good morning, Nick. I just want to check how to change that name. My name is Erika Marie Macapagal today. Good morning.
Good morning, Dr. Santian. Okay, so we'll take care of that.
Okay, thank you. I'm just wondering because I saw your first thing that rename. If I couldn't find where to get that renaming things, but can you do that? Yes.
Oh, yes, sir. We'll do that.
Thank you.
I'll take care of it. So good morning, everyone. To our speakers, colleagues, and participants, we'll be starting the event now. So good morning to all, including all our participants here in Zoom and also those tuning into our live stream. Welcome to our webinar titled Understanding Changes in Tropospheric Chemistry Through Ground-Based Measurements and Remote Sensing Techniques. So this event is organized by the Asia-Pacific Network for Global Change Research, or APN, through the Climate Change, Biomass Burning, and Biogenic Emission Impact on Surface Ozone and Particulate Matter in Southeast Asia project, the Stamina for Space Program's Advanced Satellite Development and Know-how Transfer for the Philippines, or ASP project, and the University of the Philippines Diliman's Institute of Environmental Science and Meteorology, or UPIESM. So I'm Nikki Ignacio. I'm from Stamina for Space, and I'll be co-hosting this event together with Ms. Erica Macapagal Taluban, also from Stamina for Space.
Good morning, Nikki. Pleasant morning to our speakers and everyone here with us today.
So we will now officially open the program with some messages from the heads of our organizing groups, starting with UPIESM Director Dr. Lamuel Aragones. Dr. Aragones, the screen is now yours.
Thank you, Nikki. To all the participants, I would like, in behalf of the rest of the other co-organizers and co-hosts of this event, the rest of the faculty of the Institute of Environmental Science and Meteorology would like to welcome you to this event, and I hope I could brush up on my bahasa. So, salamat pagi, good morning, magandang umaga. So it is a pleasure to be of service to the region, to share the knowledge and the research outputs that we have had in the past years or so. Today will be a great event for you to exchange and share results, share ideas regarding the changes that has been happening in our troposphere, which obviously is affecting the life that is very, very important and remarkable in the most unique feature of our planet. And so today I would like to hope that everybody will be able to speak up, share, and listen to the presenters, as well as hopefully challenge the understanding of the chemistry of our changing troposphere. Again, good morning to all, and welcome to this event.
Thank you, Dr. Aragones, for the warm message. Now we would like to call on Stamina for Space Program Leader, Dr. Maricor Soriano.
Yes. Pleasant morning to the organizers, speakers, and participants of today's air quality webinar. As program leader of Stamina for Space program, allow me to speak briefly about the program. Stamina for Space stands for Space Technology and Applications Mastery, Innovation, and Advancement. And our program aims to develop deep local expertise in both upstream and downstream space technology. Funded by the DOST, it's implemented both by the University of the Philippines and the Advanced Science and Technology Institute, or ASTI. Stamina for Space is the successor to the Philippine Microsatellite Program, and since 2016, we have built and launched two 50-kilogram class satellites, Diwata 1 and 2, and two CubeSats, Maya 1 and 2. And there are 3 ground receiving stations being put up, one each in Luzon, Visayas, and Mindanao. And the first ground receiving station, Pedro, or the Philippine Earth Data and Resource Observation Center, was established in 2016 and has capacitated us to acquire data not only from our own satellites, but from other international satellites as well. And images downloaded through Pedro has kept a lot of our scientists busy ever since. And speaking of air quality, if the troposphere above the Philippines was a movie, the first quarter of last year was, shall we say, action-packed. In January, Taal volcano, a very active volcano 100 kilometers away from Metro Manila, erupted, spewing ash that reached the capital. In February, 8 days of forest fires in Benguet burned through 900 hectares of forest and reforested land. And in March 2020, of course, the pandemic and the lockdowns. The stoppage of vehicles and factories led to noticeably clear air. My Facebook posts were filled with pictures from friends who live in high-rise condominiums who were surprised to find that they can now see mountains from afar. Thus, the talks in today's webinar are doubly relevant doubly relevant for us in Stamina for Space. Our scientists are ready to exchange findings with peers, and we are pleased to share with you data coming from our satellites. In closing, I wish you all a fruitful exchange. And even though we miss the actual coffee breaks in face-to-face seminars and conferences, I hope we can still build our networks in other creative ways. Have a pleasant day, everyone. I wish you all a fruitful exchange.
Thank you, Dr. Soriano, for that very timely message. And now we would like to hear from APN Program Leader, Dr. Justin Sentian. Dr. Sentian, the screen is now yours.
Sorry about the technical thing. Thank you, Nikki. Good morning, ladies and gentlemen. And yes, indeed, Dr. Marico, you are rightly mentions that. And to Dr. Lemuel Aragones, Director of the University of the Philippines, and all invited speaker from the EPN funded project, as well as from the UP IASM, the Philippines. Yes, as Dr. Marico mentions just now that a lot of issues that very much related to our region, especially our air quality issues, yeah? And talking about, for example, haze and high ozone episode, for example, it's a very complex atmospheric processes that involve physical, chemistry, and even the biological processes, yeah? Right from the source of the pollutants or the precursor to the formation and destruction of these pollutants, especially in the lower troposphere or even to the upper troposphere. And today's webinar will be a great platform to understand these atmospheric pollutants or compounds through the understanding of the sources, characteristic, and transport in the atmosphere, especially through the elaborations in the paper about the ground-based and remote sensing technique monitoring, yeah, as well as the probably the application of some modeling tools. Therefore, we are very grateful to have the organizer, yeah, thanks once more time, as as well as the research team from the EPN funded project to present some of the noble works related to air quality and monitoring technique. And I really hope this webinar will further enhance our networking, of course, as Dr. Marico mentioned just now, and also to the participants, our understanding on this regional air quality in the lens of various application of monitoring techniques, especially the remote sensing technique at local and regional level. Yeah, I think that's quite interesting for this webinar. With that, once again, on behalf of the EPN research project team, I would like to take this opportunity to thank the EPN for funding some of these studies. And the findings are presented in this webinar. The organizer for the outstanding effort. And last but not least, all the participants for your special interest on this subject. And I think, ladies and gentlemen, for today's, once again, thank you and have a fruitful webinar. And yes, I really echo that we can start, even though we don't have really a physical meeting on the coffee break or something like that, but we can continue on our networking in the, through any platform like this one. Thank you. Thank you, Nikki.
Thank you, Dr. Sentian, for that very insightful message. So before we proceed with the presentations, we would just like to share some of the reminders for those who just came in. So by default, kindly mute your microphone for the audience. And for Q&A, of only 5 minutes after each presentation is allotted for that. There will be more time during the open forum after all the presentations. For those here in the Zoom meeting, please type in your questions in the chat box. And for those watching the live stream, just type in your comments in the comment section. Kindly include your name and affiliation when you send in your questions, and we will try to accommodate all of them. So questions through Zoom's chat box will only be directed to the host and co-hosts of the meeting, and this meeting is being recorded and live streamed. And for the presenters, we would like to remind you to kindly keep your presentation within 15 minutes and turn on your video when speaking. So you will be reminded of your remaining time by the organizers by sending you a message in the chat box, and kindly confirm if you'll be sharing your presentation. And mute your microphone when not speaking. So that's it. We can now start with the presentations. So for our first presenter, we would like to introduce Dr. Maylene Cayetano. So Dr. Cayetano is an Associate Professor 6 and Head of the Environmental Pollution Studies Laboratory at UP Diliman IESM. In 2016, she was an adjunct research fellow at the International Environmental Research Institute, Gwangju Institute of Science and Technology, South Korea, where she also acquired her PhD in Environmental Science and Engineering from in 2012. Her presentation is titled Chemical, Optical, and Hygroscopic Properties of Particulate Matter from Urban Sites in the Philippines.
Thank you, Nikki. And yes, I agree with Dr. Justin for the outstanding arrangements by the organizers. May I be allowed to share my screen? Can I see a thumbs up if people are seeing my presentation now? Thank you. So I'll be presenting about the ground-based measurements that we conducted here in the Philippines, mostly in urban areas and some in the regional areas. My expertise are in environmental science, air and water quality, aerosol and atmospheric chemistry, and ground-based measurements. The presentation will be divided into the following: introduction of particulate matter, which is the main core of the method of this presentation, some importance of the aerosol characterization to radiative forcing calculations, and then the results of the chemical, optical, and hygroscopic properties of particulate matter from the urban site studied in this presentation, and summary and way forward. Now, a brief introduction about PM, or particulate, or any solid or droplet suspended in air. And if aerosols are solid particles, regardless whether these are vapors absorbed, there are vapors absorbed in it, these are technically called aerosol particles, or called by regulators particulate matter. Ground-based particulate matter, or PM, comes in various range and number concentration, and are conveniently described based on their size fraction in a volume of air passing through a size cut point. In this case, the size cut point can be 10 micrometer, 2.5 to 10 micrometer, 2.5 micrometer, or 100 nanometer. Aerosol particles also are present in the atmosphere because of the well-mixed characteristics of the lower troposphere, or the planetary boundary layer height, which will be discussed later by Dr. Makatangay. In the atmosphere, it's present with size ranges from a few nanometers to tens of micrometers. Aerosol particles are the result of direct anthropogenic emissions of primary aerosols such as black carbon, sea salt, it can be also dust, emission in the atmosphere, or a product of chemical reactions of secondary inorganic aerosols such as sulfate, nitrate, ammonium, and secondary organic aerosols occurring in the atmosphere. Aerosols can also be fragments of road dusts or pollen from biogenic emissions. Because of the wide range of sizes of aerosol particles, they undergo movement, and the movement varies as it goes from one place to another. Because of the component of the aerosol particles, they may undergo chemical reaction. And depending on their capacity to absorb water, aerosol particles undergo size transformation. Notice also the morphology, which will greatly impact the chemical reaction and also the interaction of the aerosols with light in the form of scattering and absorption. The color of the sky are sometimes indicative of aerosol particle composition too. Since the aerosol particles interact with sunlight, they have specific scattering and absorptive properties, and these optical properties can be estimated by the complex refractive index, or M, given in this equation, which can be decomposed into the real part, the N coefficient, which is, when plotted along the wavelength of light, gives an idea about the scattering property of the aerosol. And the imaginary part, given here as sky, that varies along the spectrum as well and have noticeably higher ranges in the near and infrared region of the spectrum. And this gives information on how much heat, HEAT, is potentially emitted by aerosol particles. The table presented here is lifted from Aerosol Optics 2009, which show the 4 major aerosol particle types and the coefficients of their complex refractive indices. So first and second column are oceanic water, or oceanic aerosols. Then the third and fourth column are the insoluble aerosol particles such as the dusts. Water-soluble particles are this in the column, such as nitrates and sulfates, and the soot particles are in the fourth column. Look how consistent the real part, or the N coefficient of the complex refractive index, assuming that, which indicates that the particles are sphere, except for dust towards the longer wavelength, which indicates the irregularity of the shape of the dust, while the imaginary part of the complex refractive index for soot is consistently getting higher as we go down the spectrum, which indicates its potential emission for heat when interacted with light. Now, the heat emitted by aerosol particles can be quantified by the aerosol radiative forcing. This is a very popular framework proposed by Haywood and Bucher in 2000. And this indicates how the aerosol interacts directly and indirectly with light, and how the rest of the unknowns or the interaction impacts the climate change or the climate variability. So the overall effect of the aerosols is net cooling, in fact, but the mixing of the particles, emission history, properties, as well as differences in surface reflectance and other radiative characteristics are still subject to scientific studies. And in calculating the radiative forcing, these are estimated using radiative transfer codes, which need near to accurate microphysical properties. These codes rely on optical models that would describe better the behavior of the aerosols in terms of radiative transfer, such as the optical depth, AOD, the single scattering albedo, the scattering phase function, at least an asymmetry parameter, and as well as scattering and absorption properties. And this understanding, if we are able to understand clearly and give the near to accurate data of the microphysical parameters, this can help bridge the gaps in scientific understanding on how the human activities impact the heat balance of our present-day Earth. From the latest assessment report by the IPCC, the aerosol cloud interaction is still at the what level? Level of scientific understanding is still low. So we need to bridge that gap. And in order to do that, since anthropogenic aerosol particles are emitted from the ground and will eventually mix with the atmospheric aerosols to take part in atmospheric chemistry and its processes, we set up devices from the ground to sample and measure particulate matter using regulatory and research grade equipments to sample PM10 and PM2.5 from the ground. And this was subjected to gravimetric analysis to determine the mass, analyzed for chemical, optical, and hygroscopic properties. For example, for the chemical analysis, we analyzed the monosugars, organic carbon, some anions and trace metals, and the elements. We also analyzed for total compounds such as the organic and elemental carbon. We characterize its optical properties by determining the black carbon level based on attenuation and the absorption angstrom exponent, which gives the spectrum dependence of the aerosol particles. And also analyze the hygroscopic growth and determine its kappa. All of this, when combined, will give a resolution of the chemical, optical, and hygroscopic properties of the particulate matter, which can then be useful for bridging the gap in the understanding of the radiative forcing brought about by anthropogenic aerosols in the atmosphere. For the measurement sites, we conducted them in various locations all over the Philippines and from intensive measurement campaigns. For example, in April to May 2015, during the Manila Aerosol Characterization Experiment, we sampled from a Quezon City roadside and urban background site, and we determined that fractions of elemental carbon and organic carbon comprises 80 to 91% of the total PM2.5, while the ions comprises 9 to 20%. A year later, we also conducted analyses in a Quezon City urban site, but this time near a hospital, and we found out that ions comprise 16%, carbon is still consistently high at 77%. Now, elemental fractions are also resolved at 1%, and there are still remaining 5% unresolved. And then in 2019, we grabbed the opportunity during a HAZE event to find out what are the identified aerosols during the transport event in 2019. This is a regional HAZE transport of Southeast Asian aerosols from burning. So the fraction of aerosols, so we identified HAZE and non-HAZE events, and by comparing the fraction of increase in particulate matter, we found out that the range of increase is from 40% to 20% in the PM concentration. And using particulate organic carbon and monosugars as indicators of long-range transport of biomass burning aerosols, it was found that there is an increase in the percentage of carbon around 32 to 122% in the region studied. Region 4B, Region 8, and Region 13, there is an increase in monosugars at 71 to 288%, and increase in ions at 15 to 195% by comparing HAZE and non-HAZE events. We also found out that the ionic balance of the water-soluble ion components shows a deviation in the 1:1 line plot as shown here, which means that the particles that reach the site has aged and has undergone transformation during transport. And then in 2020, before the lockdowns, we did some backpack measurement to determine the black carbon levels along the roadside sites in an urban background site. Again, we returned to Quezon City from February 14 to February 26, 2020. We did some morning and afternoon runs to see any variations in black carbon levels measured by attenuation. And we found some hotspots along the streets and during the morning runs, and we also found hotspots during the weekend runs. This is still on regular activities, so no lockdowns yet. So the hotspots were mostly in transport terminals, while inside the campus, this is inside the campus, the levels of black carbon are relatively low. Comparing it to afternoon levels, we also determined some hotspots along the major thoroughfare and also some hotspots in the transport terminal inside the campus. We classify the data based on the site or the area where we measured it and the time of day of run. And it shows that the major roadsides have higher black carbon concentration relative to those inside or away from the roadside. So the roadside are influenced by vehicles, but by how much? So by using the optical property called absorption angstrom exponent at 405 nanometers to 1050 nanometers, we grouped the AAE according to their ranges. And if the range fall from 0.6 to 1.33, which this means that the aerosol particles during those times were influenced by black carbon emissions. And we also identified the kappa, which represents the quantitative measure of aerosol water uptake characteristics and its relationship to cloud condensation nuclei activity, or the ability to absorb water of the aerosols. The hygroscopic parameter was computed using these equations, this the figure on the right shows the growth factor curve. This is how a growth factor curve looks like at varying relative humidity. So the highest value of 1.4, according to literature, is considered a cloud condensation nuclei active particle. And this is a characteristic of sea salt, sodium chloride, or some hygroscopic aerosols such as sulfates and nitrates. Zero value meaning non-hygroscopic. So notice that the kappa and the growth curve of aerosol particles in the urban location in Quezon City during a dry season indicates moderate CCN active particles. But let us also recall that the aerosol composition in this site is made up of at least 77% carbon components, and 50% are influenced by transport emissions. So what would be the other influencing source that leads to a high or moderate hygroscopic growth of these particles? So would the contribution from local biomass burning be significant as well? So notice that we observed large amount of water-soluble carbon component from burning solid fuels. And these are the solid fuels that we burned from an experiment. And this has not been yet taken care of in radiative transfer models. Optical properties of these aerosol particles are not well studied as well, and hygroscopic characteristics not yet fully understood. To summarize, in the rest of the Philippine sites, the fraction of water-soluble organic carbon during biomass burning season transported to the Philippines were quantified, and we observed increase in PM concentration patterns during haze events in several regions versus non-haze events. And in an urban study site, EC composition ranges from 0.7 to 21% of the PM mass. And then AAE suggests that mixed sources, 50% of samples are strongly influenced by BC emissions, and the fractions of carbonaceous aerosol particles plus moderate hygroscopic growth confirms water-soluble components. And this leads to further research questions like water-soluble, what is the implication on cloud formation of these ground aerosols? How about implication as cloud condensation nuclei? What is the mixing state of these urban aerosols, and does this have implication on radiative forcing? Can we possibly downscale the radiative forcing calculation so that we can see through an urban location? And let's consider ground-based aerosol chemistry in the radiative forcing calculation so that we can improve the estimates and improve the IPCC report. So that's it. Thank you very much. And these are the organizations and people who helped in this study. Maraming salamat. Back to you, Nikki.
Thank you, Dr. Cayetano, for your presentation. In the interest of time, we will throw questions at you, Dr. Cayetano, later during our question and answer portion. So, audience, if you have questions for Dr. Cayetano, please send them to us. Send them to the organizers, to Zoom chat box, or to comment section in IESM or Stamina for Space Program Facebook page. Thank you, Nikki.
Thank you, Dr. Cayetano and Erica. We now go to our second presentation, and for this, we would like to call on Dr. Justin Sentian. Associate Professor Dr. Justin Sentian is an atmospheric scientist and currently heading the Climate Change Research Group at the Faculty of Science and Natural Resources, University Malaysia Sabah. He is also a research fellow with the University Center of Disaster Studies and Water Research Unit, and he was a Government of Malaysia scholar at Lancaster University, UK, and obtained his doctoral degree there, specializing in atmospheric chemistry and climate change. His presentation is titled Climate Change Impact on Biogenic Emissions in Southeast Asia. So, Dr. Justin Sentian, the screen is now yours.
Thank you, Nikki. Yes, yeah, thank you, Erica. Thank you, Nikki. Right, can you see this slide on your side? Good, thank you. Right, good morning, everyone. And the next 10 or 15 minutes, I would like to share with you all the some of the research finding that we have on the impact of climate change on biogenic emission in Southeast Asia. So for most of us, I think we really understand what is this biogenic emissions is. Yeah, it is the emitted from the plants. Yeah, so biogenic emissions play a very important role in atmospheric chemistry, particularly in tropospheric ozone and eventually the secondary organic aerosol. And isoprene, which is one of the biogenic emissions, is the predominant biogenic volatile organic compound emitted by vegetations and plant, especially in the tropic. Yeah, and one of the unique things about these biogenic emissions is very much controlled by the ambient environmental variable. Most notably is the temperature and light. Therefore, if you are expecting a future climate change in any region, you are also expecting change in this biogenic emissions, because biogenic emissions is very much dependent on temperature and light. And eventually it will influence the chemistry in the atmosphere, particularly concerned on the air quality at the regional scale. Isoprene is an extremely reactive hydrocarbon, yeah, normally released in huge quantities by both natural and anthropogenic sources. Yeah, not only the plants, but you also can expect that this isoprene also emitted by anthropogenic sources. Yeah, and study in the past mentions that the natural emissions are mostly from the terrestrial vegetations, particularly in the tropics. And in terms of its rules in the atmospheric chemistry, or especially the tropospheric chemistry, yeah, isoprene is a large source of these radicals, yeah, especially the hydroxy peroxy and the organic peroxy, yeah, which can react with mainly anthropogenic NOx, which is the pollutants, to stimulate the ozone production, which is the secondary pollutants in the lower atmosphere. That is where the tropospheric chemistry come in. And this one is normally happened in an urban area where you have a lot of these anthropogenic emissions like NOx or even the other types of volatile organic compound. In remote areas, for example, in the forested area where NOx emissions are limited, isoprene can act as a sink, opposite from the one that's happening in the urban, to this hydroxyl radical, and as well as the ozone, by sequestrating the NOx as isoprene nitrates, and thereby the output is the suppressing this ozone formation. That means less ozone formations in the remote area, through this ozonolysis of by this isoprene. So there is two kind of actions by this biogenic emission, especially isoprene. And this one is showing you the global distribution of isoprene emissions, the fluxes provided by the Megan model. This one is quite some time, 2006. And if you notice that most of the emissions, especially those that in the yellow or red color, are mostly at the tropical belt, including in our region in Southeast Asia. And you don't need to worry about all these details in here, but this one is the various types of models, versions of model of Megan models, and showing you the past study that has been carried out to investigate this isoprene emissions. So this is the past study, and what the past study have estimated, the emission of just isoprene alone, it's between 350 to 800 teragram per year. It's quite high compared to other types of volatile organic compound, which is also important in tropospheric chemistry, like monoterpene and all the other 6-quiterpene and other organic things. But isoprene is the main. And what I'm trying to highlight in this presentation or in this paper is that before I'm going to explain the regional biogenic emissions and the future climate change scenario in Southeast Asia, I would like to show you how the climate change scenario in Southeast Asia is going to be under this RCP 4.5, RCP 6, and RCP 8.5. This is the climate change scenario. And the research framework involved is involving two model. One is the climate model using the we call it weather research forecast model or WRF model, and for the climate model. And the output from this climate model, especially the temperature and the photosynthetic relative, or generally we call it just the sun, the light, used as input to the second model, or the biogenic model, which is Megan, which is stand for Model of Emission of Gases and Aerosol from Nature, to project how much is the isoprene is emitted under the influence of this climate. On top of that one, other variables that are used in the model is, which is also very important factors for the isoprene emission, is the types of plant. We call it plant functional types, like different types of plants emitting different types of rates of isoprene. The left area index, some plants which are broader leaf or even the smaller types of leaf, they are emitting different biogenic emission as well as the emission factors. And on top of that one, we also carried out the climate model, which is the output from the climate models evaluations against the observations data, and this is some of the parameter that we the statistical variables that we are measure or calculate. Yeah, and the framework of this study is like the climate model, which is the output is provided by the climate model, used as input to the second model, the biogenic emission model that I mentioned to you, in order to provide the biogenic emission scenario under this climate scenario, which is the same thing with all this RCP 4.5, or either is 6 or 8.5. And the quickly on the result, just looking on this right side, yeah, just looking on the right side. This one is the climate evaluation. So this one is the temperature, yeah, just the temperature, and a snapshot on just 2 months. Yeah, this one is 2000, the present day, which is the 2013. Yeah, January and July. And this one is the RCP 4.5, RCP 6, and RCP 8.5. And the what do you call it? This one is the normalized means. This is one the normalized means square and the fractional bias. This is all statistical analysis for the evaluations. Yeah. So generally, it's like the temperature is generally the models are what they call providing a relatively quite good value. Yeah. Now, you might be interested, like, what will be the climate change in Southeast Asia? Yeah, under these 3 different scenarios that I mentioned. Yeah, in the future, if you are expecting very near to the future, the next 10 years, 2030, or if you are interested further, 2050 or 2070, or even beyond 2100. Yeah, under this 3 RCP 4.5, 6, and 8. If you're looking at those in the bracket, yeah, the red color here, we in Southeast Asia, the mean temperature is the changes of temperature is more than 2 degrees Celsius for RCP 8.5. Yeah, even during the January, which is sometimes we call it winter monsoon, or which is a wet season in our region, or July is we call it summer monsoon, which is dry period. Yeah, so we are expecting to have a slightly higher changes in temperature. The others RCP, which is actually the changes of temperature is relatively lower, and it's actually quite a good news in that sense, because if you are remembering the what we agree in Paris, agreement, something like if you can go below 1.5, yeah, so it's something like relatively good news. But that is if we have done something. But if business as usual, just like RCP 8.5, there is a concern at the end of the century, yeah, because it exceeded the 2 degrees Celsius, yeah, something to ponder about. Now, the question here is, with these changes of temperature in our region, what will be the likelihood of changes or the effect on the biogenic emissions? Yeah, and further question is the impact on the air quality at the regional scale. So this one is just a snapshot of the and the RCP 4.5, the temperature. So if you're looking at the just looking at the color here, yeah, if you see it's a red color, that means just relatively showing you it's quite high in that sense. Yeah, this one is in the present day, 2013, on your left here, and then in the second column here is 2030. The third column is 2050, and the fourth column is 2070s, and the last one is 2100. Yeah, so all the value has been summarized in the previous table. Yeah, But what is generally that you can see, for example, in July or even in January, the sea, yeah, especially in South China Sea or even in the Western Pacific here, is like actually it's quite warm, yeah, relatively. And this one, similar observations, yeah, just the value, the magnitude of changes is slightly higher, similar with the RCP 6.0, and as well as the 8.5, which is the one that we concern about, yeah. As I mentioned to you that the changes at the end of the century, yeah, 2100 compared to the present day, 2013, the temperature increased more than 2 degrees Celsius, yeah. And most of them, they are somewhere in northern South China Sea or in the northern part of the Luzon in the Philippines or in China here, yeah. Now, the second objective of this presentation is that to tell you or to show you what is the impact of this climate change to these biogenic emissions. Yeah, so we use the changes in the climate models, the temperature, as input into the Megan model to forecast or to simulate what will be the likelihood of biogenic emissions in the future under this three scenario. Yeah, so as expected, yeah, because biogenic emission is very sensitive to temperature as well as light. And what we are expecting, for example, and the RCP 8.5 at the end of this century, yeah, which is with temperature of more than 2 degrees Celsius increase of surface temperature, the biogenic emissions also increase between 30% to 58%. It's quite high. Yeah, the one in the bracket is in terms of tons per hour. This is the fluxes of the or the emissions of the biogenic emissions. And overall, what it can tell us is that the indeed the climate change do affect the biogenic emissions by generally by increasing the biogenic emission in our region. And looking at the spatial distributions of the biogenic emission in our region, most of the increase of the biogenic emissions are mostly in the tropical belt, mostly in dense vegetation cover, especially in Borneo Island, as well as in the Papua New Guinea or even in Sulawesi. Yeah, in the Philippines, I think it's a little bit lesser. And this one is very much not only due to the climate change, but as I mentioned earlier on, it's also depending on the type of vegetation. So Borneo or even in Papua New Guinea, which is densely covered with rainforests, they are emitting a lot of biogenic emissions. Yeah, if the temperatures is increase. Yeah, and for example, this one is to 2100 at the end of the century. Yeah. Even in the middle of the century, yeah, you can see that Borneo is in a hotspot, like a red color. Yeah, so Borneo is at the center of Southeast Asia. Is actually not only important as a source of biogenic emissions, but later on, I think when you hear from another speaker from Nina from University of Palangkaraya, he will talking about biomass burning from the Kalimantan experiences, also from Borneo. So you will see that Borneo is actually in the center of the issue of atmospheric pollutions or atmospheric processes. Yeah, it's very interesting. This one is the under RCP 6 scenario, which is showing you almost the same thing, but just the different magnitude. And this is the worst one. Yeah, RCP 8.5. You can see at the end of the century, 2100, you can see that Borneo is not just red, but it's turned into black, which is actually very high emissions of biogenic emissions. Yeah, especially in July, which is, we call it summer monsoon, which is we're expecting a very dry period. Yeah. So the next question, but it's not elaborating in this paper, is that what will be the impact of these biogenic emissions to the air quality, especially like the ozone, because in the atmospheric chemistry, biogenic emissions play a very important role in ozone formations, especially in urban area, but also responsible in ozone sink in remote area, for example. Yeah, so it's a very interesting phenomenon. Yeah, how these things are complicated by all the processes in the atmosphere. What more, if you are taking into considerations the haze that occurring in this region. So as more or less like what we found in this investigation is that an increase in surface temperature of more than 2 degrees Celsius, we are expecting that the isoprene increase of more than 30% at the end of the century. Yeah, and the increase of surface temperature is known or is well known to increase the photosynthetic and substrate activity that trigger the release of the isoprene. That's why the reason why isoprene is increasing. Also, the increase in plant isoprene emission is also postulated as part of the protection mechanism of the plant. That means if there increase of temperature, the plants also like adapt with the changes in temperature or hot, warmer environment as part of the mechanism to protect them, yeah, from the excessive temperature. Yeah, and in this and other studies, however, the increase of isoprene in response to the future increase of surface temperature, not all the times are what they call it increasing the isoprene, but there is also a study that when you're talking about climate change, that means there's increase of greenhouse gases, or you double up the carbon at the end of the century. Yeah, so at the end of the century, it's increase of carbon dioxide, and the increase of carbon dioxide is actually suppressing the effect of the effect on the future isoprene is actually can minimize. Yeah, it's quite two sides of the coin. It's very interesting. So as a concluding remarks, or as a summary for these presentations, yeah, surface temperature in Southeast Asia, at least at this stage, shows that at the end of this century, especially under RCP 8.5, with the increase of 2 degrees Celsius could lead to the increase of total isoprene emissions of more than 30%. An increase in biogenic emission, especially isoprene, certainly will affect the regional ozone. Yeah, either it's going to increase the ozone or it's going to decrease, yeah, depending on where you are. But also important to consider is not just this climate change, but the future land cover forcing. Yeah, the changes in land cover. If you cut a lot of trees, it might change the type of vegetation. It will affect the leaf area index. That also affect not only the isoprene, but as well as the local climate. So with that, ladies and gentlemen, before I end this quick presentations of the research under this EPN funded project, we would like to acknowledge and thanks the EPN for funding this part of investigations, the University of Malaysia Sabah, of course the University of the Philippines Diliman for organizing this webinar. Yeah, with that, Nikki and Erica, thank you very much.
Thank you very much, Dr. Cynthia, for that very comprehensive presentation. We believe the participants are still formulating their questions, so we will share them with you during the Q&A portion later. Once again, thank you very much, Dr. Cynthia.
Thank you.
Thank you, Erica and Dr. Cynthia. We now go to our third presentation, and for this, we would like to introduce Dr. Nina Yulianti. So Dr. Yulianti is an associate professor in the University of Palangkaraya, Central Kalimantan, Indonesia. She finished her doctor's degree in Graduate School of Engineering, Hokkaido University in 2013, and has actively participated in various programs and gained a diploma in Special Coordinated Training Program for Sustainability Leaders in the Center of Sustainability Science, Hokkaido University, as well as the Prosper.net Leadership Program Initiative from UNU, AKEF, Ministry of Education Malaysia in 2015. The title of her presentation is The Impact of El Nino Induced Peak Fire on PM10 Levels in Indonesia. Dr. Yulianti, the screen is now yours.
Okay, thank you, Erica. I will share my slide. Okay. Yeah. Can you see it? Okay. Good morning, everyone. Nice to meet you in this online seminar. Firstly, I would like to deliver my gratitude to the APN team and also faculty member of University of Philippines for this great opportunity. Hopefully, all of us still healthy during this pandemic. I will try my effort to shorten this presentation as requested. If you have any question, you can email me by these emails. My title of presentation, like mentioned before, is the impact of El Nino induced fire on PM10 level in Indonesia. This is collaboration from several institutions in Indonesia or in Japan. Okay, this is the outline of the presentations. Some of you, or even most of you, have known the forest fire is part of our community in Southeast Asia, including in Indonesia since a long time ago. However, the tropical field fires, or the underground fire, have been strongly noticed since strong El Nino in 1997-1998. And then Indonesia suffered by very strong El Nino in 2015. After the worst fire events, Indonesia government announced that there are 7 provinces as priority for the wetland restoration due to the large area of the burn. The total area of the burning is about 2 million hectares. So in 2015, like I mentioned before, fire occurrence took Indonesia to the spotlight regarding the transboundary haze among Asian countries. But in other side, our capital country is also marked as one of the most polluted city in Asia. Therefore, we decided to show these comparisons between the condition as one of our objectives. This one. The study site is cover all of Indonesian province, but we also point out some the areas such in Central Kalimantan, or we know this is the Borneo Islands. The data source taken from the ground station and also from remote sensing data from some open source website like in this one. And our first research, we try to figure out the pattern of fire occurrence in Indonesia. This is updated from our previous publication in 2012. Like you see in this figure, we can see the last annual fire occurrence from 2014 to 2020, like this one. Total number of Indonesian fire or hotspot was about 17,000, or this is higher than the last decade from our previous publications. The reason is because some of the province, like this is one of the example, the gray one, this is the province of Papua that is close to the Papua New Guinea in this eastern part. The number of fire in this province increased 3 times larger than previous decade. Papua actually is the last frontier of the tropical rainforest in Indonesia, because this province still consists 70% of the primary forest and pit swamp forest. As Dr. Sentian mentioned, if the future burning and some human activity still disrupt this forest, this one of island become really hot or in the red colors. So we want to know letters, even the Papua fire is the pit fire or underground fire, or only ordinary fires. Next, we want to show you this, the origin of the fire. We divided the day fire and the night fires. Day fire mostly refers to the vegetation fires or surface fires, and the night fire refer to more the pit fire or the underground fire. Both fire occurrence peaks. However, the peak of the night fire is apparently a delay compared to the day fire. This is actually consistent with what we see in the field and the sum of previous study. The pit fire or underground fire only occur when the fuel in the surface or when the vegetation has run out, and this pit fires was quite dry due to very long drought and the low groundwater level in the peatland area. Here you can see during 2015, there is 3 provinces with the highest number of fire or hotspot. This is the central Kalimantan here. This is in the middle of the Borneo, and also in Sumatra Island here in the southern part of Sumatra, and this one the Papua Islands close to the Papua New Guinea. If we divided this fire occurrence by day and by night, so we can notice the type of the fire, like in the central Kalimantan and the South Sumatra, the type of fire is dominated by pit fires or underground fire. But in the fire, Papua are dominated by vegetation fire, like here the red one. And the next, the top fire in the another's El Nino years, still Central Kalimantan as the top of the fire occurrence. So we want to see how the spatial patterns of the fire in this province in Central Kalimantan. So we can see the most of the red color in this map occur in the south and the southeast part area of the islands. It is coincide to the deforested area or convert peatland area for some reasons. Next, because we know the condition of the fire, we want to see the comparisons between the most pollutant city and the most fires prone area. Like here, we take the data from ground stations. You can see this is the image from the Great Jakarta, the capital city of Indonesia. This is the image from Central Kalimantan, the most fire-prone area. If you compare the previous one and this figure, you can see the air quality in Jakarta city is much better than in Central Kalimantan. Because during the fire season or heat season, the level of PM10 in Palangkaraya or in Central Kalimantan is very high, exceeding the dangerous air quality level. Someday it will reach the 3,000 microgram per meter cubic, like in El Nino year 2015-2019. Unfortunately, when we want to show more result, we have lack of the data because the station in Central Kalimantan is only one station. This station, another station shut down because of some of the reasons. So from this station, only one station, clearly pit fires, or we can say underground fire, cause the worst condition in this province. Based on the regulation in our country, if this day or the number with the hazardous air quality still come in the future. So it will be have very negative impact to the future generation, not only in Indonesia, but of course in Asians. So to determine the association between air quality and public health, we try to conduct some of the future research. Unfortunately, difficult to find the really good data from the ground station because, like I mentioned before, we only have one station in that area. So it's possible to use the data from another station to fill out the gap during the fire years. So we try to use remote sensing data taken from MODIS, Terra, and Aqua. So this is image, the scatter plot of the MODIS, Terra, and Aqua versus the ground data. So you can see here some of air pollution or PM10 level only concentrates between the 2 to 3 AOT in 2015. However, the number of PM10, this is reached over than 300 microgram per meter cubic. Here we found some disadvantage from this method. We can see the correlation between AOT and the observed PM data in our central Kalimantan station was quite low because of both data, AOT, and also observed PM has blank data in some day. Like it's more than 10-day blank data during the El Nino years. So there is also some outlier data from the observation data. For example, PM10 data reach very high, but AOT data do not show the number different than the daily average. So we hope to find another way to be solution for our futures association between PM and public health. I think this is the last presentation from me. So we try to install some sensor in some area and try to assess the impact of the the bad air quality, and also we establish the small laboratory in the public school to know the effect of the photochemical smoke on the indoor air quality. So thank you everyone for your attention in this presentation. So I think this is my presentation. Next schedule I return back to the moderators. Thank you.
Thank you very much, Dr. Nina Yulianti, for your presentation. Similar with the earlier presenters, we will send your questions later during the question and answer portion. Thank you once again.
Thank you, Dr. Yulianti and Erica. We will now proceed to our fourth presentation. And for this, please welcome Dr. Ronald Makatangay. Dr. Makatangay is a researcher at the National Astronomical Research Institute of Thailand in Chiang Mai, Thailand, currently researching on complex terrain and maritime atmospheric boundary layer meteorology, aerosol PBL interactions, particle size distributions, eddy covariance measurements, long-range air pollution transport, and tropical cyclones. He obtained his Doctor Rerum Naturalium in Environmental Physics from the University of Bremen, Germany, and he is also an adjunct professor at UPIESM. His presentation is titled The Mixing Height and Particulate Matter Concentrations. So Dr. Makatangay, the screen is now yours.
Thank you, Nikki. I'll just share my screen. Okay. Okay. So as Nikki pointed out, I'll talk about the concept of the mixing height and particulate and how it relates to particulate matter concentrations on the surface. So first, what's the mixing height, or sometimes called atmospheric boundary layer or planetary boundary layer? Sometimes it's also called that way. So it's the lowest part of the atmosphere, which is in close contact with the surface, And because of that, since it's in close contact with the surface, that's where most of the mixing occurs, or most of the turbulence occurs. And if you have PM2.5 concentrations, it will be well mixed in this layer, or in the mixing height, or the atmospheric boundary layer. So that's why it's called the mixing height or mixing layer height. So this have some variations throughout the day. So in the daytime, where usually you have warmer surface temperatures, higher solar radiation, so basically you have a stronger turbulence, so the mixing height is generally higher. And if you have, let's say, that level of mixing height, and then you have PM 2.5 concentrations of the surface, if you measure, if you have your surface measurements, then you would be generally measure lower, relatively lower surface PM 2.5 concentrations during like the late afternoons, where you have a high altitude of the mixing height. But the opposite is true during the nighttime. So during the nighttime, you have cooler surface temperatures. You have you have no solar radiation, so you have lesser turbulence in the lower part of the atmosphere. So your mixing height or PBL height is generally lower. And if you have, let's say, the same amount of emissions of PM 2.5 as in the daytime, in the nighttime, you will notice it would be a higher surface PM 2.5 concentration because of the lower volume for the air to disperse during the nighttime, especially. So, so what affects the motion or the variation of the mixing height, like being high during the daytime and being low during the nighttime? So it's affected by, of course, the sun, the surface temperature, winds also affect the mixing height, and the topography as well. So all of these are some of the common factors that affect the variation throughout the day of the mixing height or the PBL height. So this is just an example in so where I work in Chiang Mai, Thailand. So we use the atmospheric LiDAR to estimate the mixing height in the valley atmosphere. So as you can see in the like in the early morning, it's quite low. So the blue dots in line is the atmospheric boundary layer height or the mixing height, at the left-hand scale in kilometers. So the x-axis is the time in local time. So usually it's very low during early mornings and starts to rise around like for this location. So it starts to increase like around noontime and reaches its maximum at around late afternoon or even early evening, and then it starts to go down again throughout the nighttime. And how does this affect the particulate matter concentrations? Or in this graph, if you look at the right-hand side, that's your particulate matter concentration in microgram per cubic meter. So when the mixing height is low, like here during this lowest part of the during this time, the particulate matter concentration is quite high because you have a low mixing height, so lower volume for the particulates to move around or to disperse. And then during the late afternoon, the mixing height is higher, so you get a lower surface particulate matter concentrations. So visually, it would look something like this. If you're, let's say, on top of a mountain or on a hill, you can see like in the morning, you can clearly see this boundary of pollutants, and that indicates your mixing height level. when in the late afternoon, it would look probably something like this. So you have a higher mixing height, so increase the visibility in the afternoon. So usually you'll notice this if you have hourly measurements of particulate matter concentrations. You will see this pattern generally throughout the day for several days. Okay, so the mixing height, as I said a while ago, it changes also due to topography. So it can change, or its characteristics can change from one place to another. So you can see it here in this model simulation over Indochina Peninsula. So the colors indicate the atmospheric boundary layer height in kilometers. So as you can see, in areas where it's flat, for example, here in the northeast of Thailand and in the central part of Thailand, including Bangkok here. So the mixing height is generally higher compared to the north of Thailand, for example, and these parts of Laos and Myanmar, because it's mostly a mountainous area. So usually in the mountainous areas, the mixing height is generally shallower or generally lower due to effect from the topography. And due to the winds, so for example, there was a storm that was coming onshore in Vietnam, and that also changed the mixing height somehow. Okay, so that's how it changes through location. Now, how can we estimate the mixing height? As I mentioned earlier, we used light detection and ranging technology looking upward. So we call it an atmospheric LiDAR. So we shoot the laser into the atmosphere, and if the laser encounters some particles in the atmosphere, it will backscatter. It will have a return signal. So if it's some particulates, it will be like a broad feature. If it's clouds, and it will be like a sharp feature. And you can get also the altitude information of your particulates. So this is how it looks like, and this is our instrument in Chiang Mai, the atmospheric LiDAR. So in theory, the boundary layer would have this structure. So it will have a stable boundary layer in the early mornings and during the nighttime, with a residual layer on top and what we call a capping inversion at the top. And once the day starts, solar radiation increases, surface temperatures increases, so turbulence increases. So this stable boundary layer will slowly change to what we call the mixed layer, where we have good mixing or well-mixed part of the atmosphere. And the capping inversion is, we now call it the entrainment zone. And usually the LiDAR will estimate the top of that mixing layer in the daytime. And if you compare it with model, usually the LiDAR estimates and the model would have a good agreement during the well-mixed times of the day, like during the afternoons. However, the model the LiDAR estimates during the nighttime, normally it will detect the top of that residual layer, while the model will usually calculate that stable boundary layer. So there's a need to improve these estimates. Instead of detecting the top of that residual layer, so we try to also detect the top of that stable boundary layer. And this we try to do, improving the mixing height estimates from the LiDAR by introducing some time-dependent limit for the mixing heights. And so this is in theory, as you can see here, and this is in reality what we can see from the LiDAR. So the x-axis is the time in UTC in this case. So the y-axis here is the altitude. The colors are the amount, actually the number of particles in the atmosphere. So if you have a higher, let's say if you have a greener color, that means it's a higher number of particulates. So blue indicates lesser particulates. And then the white would indicate some of these clouds. So the yellow triangles are the estimated mixing height. And so it's usually estimated by detecting the maximum change in the number concentration of these particulates. And if you don't improve your the mixing height somewhere here during the nighttime, as you can see here, so this is not correct. But if you introduce, for example, some limiting factor during the nighttime, especially, so you would be able to improve your mixing height estimate. So as you can see, during the nighttime, the mixing height is quite low. However, above the mixing height, you will still observe some of these like elevated or above the PBL height, you will observe sometimes particulates hovering above the surface as well. So this is just some results from this year's haze season in Chiang Mai, Thailand. So this is during December, where it was still relatively cleaner. So so again, the x-axis is the time. This time it's in days of the month. Let's say in this case of December. So the y-axis on the left is the mixing height, hourly average mixing height, and on the right is your particulate matter concentration, hourly averaged again, or hourly sampled particulate matter concentration. So you can see this is during December. So the red bar graphs, they are the PM, and then the blue line is your mixing height or PBL height. So as you can see, you have the regular up and down movement of your PBL height or mixing height here. And then if you average all of these data throughout the month, so you come up with this bottom plot. So we plot it versus time of the day. So from 0 to 24 hours. So you can see, so the mixing height during December will start to increase like around before noon, and then we'll reach its peak in the afternoon. And the particulate matter concentration, the average particulate matter concentration will sort of have some anti-correlated relationship with the mixing height. So, so mixing height affects PM concentrations. However, interesting question is, like if we go the other way around, can particulate matter concentrations affect the mixing height? I think this was also explained in the first talk by Dr. Mylene about the effect of aerosols or particulates on the radiative properties. So the mixing height, of course, is very much affected by radiative properties, since it depends on solar radiation and in effect surface temperature and turbulence. So if there is, for example, a lot of black carbon emissions, like from biomass burning, so it will release a lot of this black carbon or brown carbon. And this black carbon or brown carbon will generally have a warming effect at almost at the top of the PBL. And if it warms that part, it will like induce some sort of inversion, and that will reduce the amount of turbulence or mixing as compared when, let's say, there is no black carbon. So you have like a normal amount or normal intensity of turbulence, normal intensity of mixing. And then if you have black carbon, that turbulence or mixing is a bit inhibited or reduced. And you also get dimming at the surface, and also relatively cooler at the surface because of that black carbon, which may come from emissions from the surface, from biomass burning, from vehicle, like from soot emissions, and industry as well. And this produces some sort of a positive feedback if those emissions keep on happening. So that will increase the pollutant, the PM concentrations in the atmosphere, and that will reduce turbulent mixing, and that will reduce your boundary layer height or your mixing height. And if your boundary layer height is lower, then that will keep on increasing your pollutant, and that will have a cycle or a positive feedback loop. And this is somewhat we observe also in Chiang Mai when the pollutants are a bit increasing. So this is in January. So pollutants started to increase, or the PM concentration start to increase. So there would be some instances where the mixing height behavior would be a bit lower compared to your normal. So this is in January. This is in February, where the biomass burning starts to increase and the PM starts to increase. So like in this region, very high PM concentrations, also here, high PM. So you have a relatively lower mixing height, or the PBL height is somewhat inhibited, or the PBL height development is inhibited. And then during March, where we have the peak, so notice the change in the scale here of the PM from maximum of 140 microgram per cubic meter up to 250 microgram per cubic meter. So during March, where we have a lot of biomass burning and a lot of black carbon in the atmosphere, so the PBL height or mixing height is really, or the daily variation of the mixing height, the maximum is generally reduced, also here in the average. Okay, so this is my last slide. So how is this related, for example, to satellite remote sensing? So we know that satellites estimate the aerosol optical depth. And normally they use this AOD to compare with surface PM concentrations. And from there, you can derive a PM. However, if you have also information of the mixing height, you can come up with what we call a PBL AOD. And since most of your pollutants on the surface are limited in the PBL, so if you can come up with a PBL AOD, so that will greatly improve your comparison with the surface PM concentration. Okay, thank you very much.
Thank you very much, Dr. Makatangay, for that very clear presentation about the mixing layer and particulate matter. One question from our participants: how do you correct estimates or measurements from LiDAR?
Okay, so when normally you set some like maximum limit to the mixing height. So normally it's just set like a constant value, let's say throughout the day. So you can set that at a certain height, also the minimum, so the minimum and maximum. But if let's say if you can introduce based on theory as well, so by theory you know that it should start to increase in the early part, or let's say at some point, let's say before noon, for example, and then it will reduce during the evening. So you can introduce some like time-dependent limits. And well, yeah, once you know this, and then once you do some validation, you can validate if you have vertical profile measurements, like using balloons or other measurements, then you can validate this method.
Okay, thank you very much, Dr. Makatangay. The other question for you, we will share it later during the question and answer portion. Thank you once again, Dr. Makatangay.
Thank you.
Thank you, Dr. Makatangay and Erica. We are now down to our fifth presentation. And for this, we would like to introduce Engineer Rose Ann Ramos. So Engineer Ramos is a faculty member of the country's Center of Excellence in Geodetic Engineering, the UP Department of Geodetic Engineering, or UPDGE, and a researcher with extensive experience and involvement in scientific and government programs and projects related to geographic information systems, remote sensing, and global navigation satellite systems with environmental modeling and geospatial applications. She obtained her Master of Science in Geomatics Engineering or Geoinformatics degree from UP Diliman. Her presentation is titled Remote Sensing for Air Quality Monitoring. So Engineer Rose Ann, the screen is now yours.
Thank you, Nikki, for the warm introduction. I'll share my screen. Okay, may I know if my screen is already shown?
Still loading on my end, ma'am.
Okay, thank you. Okay, again, I'll introduce myself. I'm from or focus more on the geomatics applications of air quality monitoring. So using spatial technologies like remote sensing and GIS or geoinformatics. So my presentation would, while it's still loading, my presentation will focus on few concepts of remote sensing, how it is related to air quality, and previously Dr. Makatangay already shared that we can use satellite data in integrating the outputs of his research. So later I'll discuss a thing about that. And also we made a case study in the Philippines recently because of the pandemic. So I'll share our initial findings, and currently this is in progress in collaboration with Dr. Maylene Cayetano and Dr. Jerry Bagtase, and also my fellow faculty from the Department of Genetic Engineering, Assistant Professor Ayin Tumandong. Okay. May I know if my screen is already up? The presentation is already
Still loading, ma'am.
Okay. I'll retry. Thank you.
Okay. Let's just wait for a moment. There. It's okay, ma'am.
Okay, thank you. Okay, sorry for the delay. So I'll proceed with my first topic. So that would be in concept of remote sensing. Basically, remote sensing is a specialization involving the science and technology of acquiring information about the Earth's surface. So that would be, it may be in land, in ocean, and the atmosphere. We make use of different sensors on board different platforms. Our platforms may be aircraft, drones, or unmanned aerial vehicles, or space shuttles and satellites. So this presentation, I'll be focusing on satellite measurements. Analysis of images and related data obtained from this type of instruments or sensors are based on the recorded measurements representing the interaction between our matter, which is in our case, the target object, the atmosphere, or the area of interest or phenomenon like air quality concentrations, and also the electromagnetic radiation. So the concepts of remote sensing are based on the concepts of physics, and earlier, Dr. Maylene Cayetano already discussed some properties of aerosol and how they interact with light. So in general, objects react differently when light is reflected, absorbed, or emitted, depending on their structural and chemical properties. Then the intensity of this radiation, either reflected or emitted, is influenced by the surface, ground properties, and our atmospheric conditions. So again, in general, we have two types of remote sensing systems, that is passive and active. Passive systems detect naturally occurring radiation. It can be radiation emitted by the sun or reflected by objects, or thermal radiation emitted by our objects, not at absolute zero. On the other hand, active systems such as LiDAR, the one presented by Dr. Makatangay, emit radiation and analyze what is sent back to the sensor. So in this presentation, I will discuss a case study focusing on the geomatics application of satellite data and air quality monitoring. Satellite measurements contain information about the surface and atmospheric conditions. So these types of sensors or the satellite platform can detect backscattered UV, visible, or emitted thermal radiation. So sensors such as spectrometers, so there are different sensors on board our satellite vehicles. One of them, imaging spectrometers, which basically measure gases in the atmosphere. So in our air quality applications, this type of spectrometers measure light that is absorbed by the gases in our atmosphere. From these spectral measurements, a distinct absorption spectra of each trace gas, or which we call the spectral fingerprint of each atmospheric constituent, can be identified, and subsequently we can retrieve column average concentrations depending on what type of pollutant we are investigating. So there are retrieval algorithms or models that usually infer physical quantities such as the particle number density, partial pressure, and column amount. So the focus of air quality studies in other countries utilizing RS techniques is in understanding mainly the aerosol dynamics, especially in our urban environments, with the goal of improving forecasting and modeling of our air quality parameters. So how can we use RS? It greatly contributes determining pollutant concentrations at regional and national scale. So in this case study in Metro Manila, we are demonstrating how remote sensing can help in our air quality monitoring and reporting. So as shown in the map, we have different monitoring sensors or continuous monitoring fixed stations in Metro Manila area. Poor air quality has been reported in this region, and most of the impact studies are focused here. However, the fixed monitoring stations, the available ones and the operational ones, they do not actually fully characterize the changes in space and time of the pollutant concentrations, possibly to several reasons. It may be because of insufficient number of monitoring stations with 16 cities in the area, limited availability of information or sensors that can measure all pollutants. So in this case, only PM 2.5 or PM10. And then can be due to recording gaps as shown in our graph, wherein there are a lot of missing values in a daily basis, or other operational problems like maintenance of the sensors. So to address those limitations, satellite measurements were explored. In our case study, specifically, our objectives are to demonstrate the use of satellite data in monitoring the atmospheric pollutants or air quality in a regional scale, and to determine the temporal and spatial variations of air pollutants. So that's specifically nitrogen dioxide using Sentinel-5P tropomi measurement. So the Tropospheric Monitoring Instrument, or tropomi, is a spaceborne nadir viewing imaging spectrometer covering wavelength bands between the ultraviolet and shortwave infrared. So the instrument is the Sentinel-5P. Its single payload is the tropomi sensor, and uses passive remote sensing techniques to attain the objective of measuring the top of atmosphere and the solar radiation reflected by and radiated from the Earth. This instrument, as shown in the illustration, operates in a push broom configuration with a swath width of around 2,600 kilometers on the Earth's surface. So that gives us a typical pixel size of 7 by 3.5 kilometers. So that's the spatial resolution. And the temporal resolution is at daily basis. So meaning it makes one measurement per day. In this study, we used level 3 products, meaning the products are already pre-processed with instrument calibrations applied, radiances and geolocated values already obtained, and the air quality parameters are represented in atmospheric optical depth or vertical column densities, or VCDs. So if you want to know about the different products and retrieval algorithms for the Sentinel-5P tropomi, you can visit the website of European Space Agency, specifically the Copernicus Open Access Hub, as shown in this slide. So in summary, the NO2 vertical columns are observed from space and were results of emissions of nitrogen oxides formed by different fuel combustion processes like fires, lightning, and soil. So NO2 columns serve as a proxy of this nitrogen oxide emissions if averaged appropriately in time and space. Other supplementary satellite data also utilized in the study were compared with the NO2 tropospheric concentrations. And these are global climatary analysis data from ERA 5, cumulative rainfall data from GSMAP, and another sensor called MODIS for the daytime and nighttime land surface temperature. Again, so these data sets are based on remote sensing techniques and are available online. So you can check also in Copernicus Hub for these types of data. Software utilized in this study are primarily for the mapping application. So Google Earth Engine was used to access the cloud-based software where we can access different archives of remotely sensed data. We have online repositories. Scripts can be created using built-in libraries, and functions were used so we can extract the NO2 measurements from Sentinel-5 Tropomi and also the other variables or meteorological parameters stated earlier. These measurements were exported to geographically referenced image files using the Google Earth Engine scripts. This cloud computing service, again, is free and you can access this anytime provided you have internet connectivity. Initial visualization and checking were done in Google Earth Engine also, but post-processing of data such as converting to CSV, manipulating of data sets to our maps, and further analysis for spatial and temporal variations were done in GIS software. One example output of the study are maps of the monthly average of total vertical column concentration. So again, these are tropospheric concentrations, relative concentrations only, because this should be verified on the ground. Since we do not have access to data by this time, we were not able to do validation. So again, these are relative measurements from July 2018 to September 2020. And as you can see, red portions mean higher concentrations, blue ones or blue regions means lower concentrations. By visual analysis, relatively high concentrations can be found on central part of the region. So the goal of this study is only to show how NO2 concentrations relatively occur in the Metro Manila region and which parts or which cities contain the highest relative to other or neighboring cities. So the visual trend is evident in both years 2018 and 2019. So that was pre-pandemic, specifically for September to November period. And as you can see in the maps, the cluster of high levels is shifting from east to west. So the areas affected by this cluster are specific for cities, Quezon City, Manila, San Juan, Makati, Pasig, and Mandaluyong. So we have correlated these data sets with pollutant meteorological parameters in order to check how much or how dependent are these pollutant concentrations on weather conditions. Right. So in other scenario, we also compared it to wind conditions. So to visualize the effect of wind speed specifically, we plotted or generated wind plots in comparison with the monthly average map. Sample is shown here from July 2019 to December 2019. Wind rose diagrams show that the prevailing wind conditions per month in the region are as follows. So wind velocity measurements from July 2000 to December 2019 indicate that strong winds occur from July to September and predominantly move from southwest to northeast direction. So this pattern is similar to the shift of the cluster of high pollutants. But for relatively low conditions during October in 2019, this contribute to the high concentrations in the southwest and central parts of the region. In a monthly basis, this is further compared with NO2 and meteorological parameters, and the significant findings include the following. High air temperature occurs from the month of April to June, and then with the land surface temperature that is during the daytime and nighttime, high variability occurs during nighttime, while in months except in March and June. For daytime LST, relatively high variability occurs in March, July, and the period of September. So these are just our initial findings, and we have continued plotting it until March 2021. To quantify these relationships, not just by visual comparison, we also used a statistical method of the Kendall correlation analysis. So this correlation matrix plot shows the distribution of the variables on the diagonal and the correlation coefficients on the top of diagonal, and the bivariate scatter plots with the fitted line at the bottom of the diagonal. So the results show that based on daily measurements, wind speed has the highest Kendall correlation coefficient, equal to 0.42. So NO2 has a negative correlation with wind speed and a positive correlation with air temperature, and LST for both daytime and nighttime conditions. The relationship between NO2 and cumulative rainfall is, on the other hand, not statistically significant. So additional scenario in this study is through the investigation of spatial variations of the satellite-based NO2 concentrations before and during the implementation of the enhanced community quarantine in Metro Manila, as illustrated in the weekly average map. So take note that ECQ was officially announced last March 16, 2020, and then ended by the week of April 30. So for quick assessment, we did this study in order to know what's the possible effect of the lockdown or community quarantine measures in the area to our NO2 concentrations. So relatively high NO2 levels are found during the weeks before ECQ, and clusters are seen on the central portions of the region. So by visual analysis and by checking the land use of the area, the central part mostly contains dense buildings or clusters of buildings or infrastructures in the region. While during the ECQ period, low levels of NO2 are observed and are more dispersed relative to the previous weeks. So the concentrations tend to move in the northeast parts of the region, as what is shown or visible in the pre-pandemic situation. So these observations are similar to what has been published and reported in other major cities in other countries such as Beijing, Delhi, and I think some of our neighboring countries also in the Southeast Asian region. So in the case study discussed, take note that relative concentrations in the horizontal plane were estimated. So very little information can be obtained on the vertical distribution of trace gases in the atmosphere when captured from a nadir view. Similar studies used integration of passive remote sensing and active remote sensing such as LiDAR, as presented by Dr. Makatangay, and atmospheric chemistry and dispersion models for better resolution and vertical representation of results in monitoring air quality. So I hope these outputs can provide insights and be used extensively in other applications, such as in reducing emissions, identifying attainment and non-attainment areas, emission inventories, and energy usage studies. I believe various satellite data products and their specific applications for air quality monitoring will be discussed later by the succeeding presenter. So I will end my presentation here. Thank you everyone for your time, and especially to our organizers for the invitation and in excellent handling of this event. Maraming salamat po.
Thank you very much, Engineer Rose and Ramos, for your very informative presentation. A question from the audience. Among the satellite data products used for air quality monitoring, which among them has the highest accuracy and most suitable for use in our country? And for the students and young researchers present with us now, which among the satellite products would you recommend in terms of the ease of processing and use for beginners who would like to study or make use of satellite data products?
Yes, thank you, Erica. I believe in the last presentation, different satellite products will be discussed. So maybe Dr. Gay Perez would answer that in terms of the accuracy, right? We have different factors to consider. The presentation or the case study I showed earlier, I cannot say at what extent is it accurate because we do not have a validation data for that. But in terms of ease, convenience of use, and accessibility, I think one of them is already the Sentinel-5 P-Tropomi. Earlier versions of that would be from OMI, Ozone Monitoring Instrument. And then there are also other data types like MODIS, Landsat, and Sentinel-2 or Sentinel-1. However, I have not tried processing them directly. We can do that in Google Earth Engine as well. But maybe for the interest of the discussion, I think if ever we need quick assessment for that, it can give you the latest and the updated parameters or updated values. So that would be in a regional scale or national scale. So you can resample actually. If you want higher spatial resolution, you can do resampling. So it may be for, let's say, you have a different approach for ambient or for roadside monitoring. So I guess Sentinel-5P can only be used for ambient reporting. If you want roadside, it might be better to use higher spatial resolution like Landsat or MODIS. And thank you, Erica.
Thank you, Engineer Ramos, for your answer. We hope we were able to give some advice to our young researchers here who would like to delve into processing satellite data products for air quality monitoring. More questions later, Engineer Ramos, during the Q&A portion. Thank you once again.
Thank you.
Thank you, Erica and Engineer Ramos. So we are now down to our 6th out of the 7 presentations. And for this, I would like to introduce Dr. Jerry Bagtasa. So Dr. Bagtasa is an assistant professor too at UPIESM, a research fellow at the Oscar M. Lopez Center, and is the creator of the Weather Manila Facebook page. His research interests include atmospheric science, meteorology, aerosol, LIDAR, and air pollution. He obtained his Doctor of Philosophy and Science from the Center for Environmental Remote Sensing from Chiba University in Japan, Artificial Systems Division, Optics and Electronics, Atmospheric Physics on a Japanese government scholarship program. His presentation is titled The Philippine TCCon Total Carbon Column Observing Network Site. So Dr. Bagtasa, the screen is now yours.
Thank you. Good morning, everybody. So I'm going to... Yeah. So I'm going to talk about some of the measurements we did a few years ago in Northern Philippines, and I'm also going to introduce the Total Carbon Column Observing Network here. So again, I'm Jerry Bagtasa with the University of the Philippines IESM, and let me also introduce the primary investigator of the TCON Philippines site, Dr. Morino, and Dr. Chino of the National Institute for Environmental Studies in Japan. And the overall coordinator of this project is Dr. Velasco. So next, please. So as mentioned by almost all of the presenters before me, Asian emissions are pretty high. And in fact, in more than 2 decades now, we've been emitting higher emissions compared to the Western world. So aside from anthropogenic industrial emissions, we are also emitting a lot of biomass burning, which also creates a lot of emissions essentially in our region. Next slide, please. And on top of that large emission, there's also a lot of weather phenomenon that's happening all around us. So from summer to winter time, we have the monsoon, we have very deep convections, we have certain mechanisms that can carry these pollutants to other places on Earth. So essentially, we have large emissions and very complex meteorological interactions. Next slide, please. So let me introduce the total carbon column observing network. So this is a network of essentially ground-based measurements of CO2 all over the world. Next slide, please. So the TCON in the Burgos site or in the northern Philippines is from the National Institute for Environmental Studies in Japan. So it consists of essentially two equipment, the FES or the Fourier transform spectrometer. So it is used to measure essentially CO2 or column CO2 in the atmosphere. We also have the Raman LiDAR system, which essentially measures aerosols in the atmosphere as well. And it's been operational since March of 2017. Next slide, please. The FTIR or the FTS essentially looks at the sun and it measures the absorption of CO2. So the more the CO2 that is in the atmosphere, the more absorption in solar radiation, and we are able to quantify the amount of CO2 in the column of air right above FDS or the FDIR instrument. For the LiDAR, it was mentioned by Dr. Makatangay earlier that we essentially shoot laser beams into the atmosphere. And once they encounter things like aerosols and some other gases, the backscatter can be measured and it gives us information about the aerosols in the atmosphere. Next slide, please. So what we did in 2017, spring of 2017, was together with the measurements of the TCON, we also did PM2.5 chemical sampling. So the chemical sampling, essentially, these are 2-week, 24-hour sampling for each of the season, but I'll be presenting the measurements we did on March of 2017. So we measured the ionic, metallic, organic components of the aerosols, and we also did measure some mercury in the atmosphere, but I will be discussing that in here. So next slide, please. So the upper figure you can see is a 1-week measurement from March 9 to 16 of 2017. So what you will immediately see, I suppose, is that there are two high pollutant events in the 1-week period. At the beginning of the measurement, of the week-long measurement, the PM2.5 concentration was around 25, which is relatively high for a rural region. And then all of a sudden, it went down to around 5 to 10 per cubic meter for the next several days. And at the last day of the week-long measurement, again, it went up to around 25 microgram per cubic meter. It's the same thing for the components of the PM2.5. We saw more sulfates during the high concentration events compared to the low concentration events. And at the lower figures essentially show us the path of the air trajectory during the high concentration events. Those are the red lines, and the low concentration events, which are the blue lines. So for the high concentration events, we can see that essentially the pollutants, the air, they are coming from northeast of China, and it goes directly southward from northeast of China to the Yellow Sea, to the East China Sea, and then the northern part of the Philippines. For the blue line, the lower concentration days, what we're seeing is that there's a ridge in the East China Sea, and because of this ridge, there's most of the movement are northeasterly rather than northerly. And because of this ridge, most of the air actually comes from the East China Sea rather than the northeast of China. So that's one of the main difference between these 2 days. Next slide, please. So by looking at the chemical component that we measured with the PM2.5, we were able to apportion the sources or identify the sources of this pollutant. So we identified 6 sources of pollutants that we measured in Northwest Luzon. So these are sea salt, dust, and solid waste burning. Most of these are present all throughout the year, so for all seasons. But we also found in the lower plots long range transport sources. So first is the industrial emission, secondary sulfate, and solid waste burning. And most of this long range transport, they don't appear during the summer or fall season. They appear mostly in the winter and particularly in the springtime. So that's the reason why during springtime, that's what I wanted to show you in the measurements of March 9 to 16 of 2017. So if you look at the table below towards the rightmost, the under annual, you can see that some of the pollutants of around 1/3 of the PM2.5 in the region. And then 1/3 is due to solid waste burning, local solid waste burning. So it's customary in rural regions in the Philippines to essentially burn falling leaves instead of throwing them out properly. So that contributed to the large, quite a large number, 1/3 of the PM2.5 there. And then 1/3 are due to long range transport from industrial emission, secondary sulfate, and solid waste burning. The next slide, please. We wanted to know how this occurs, how the transport occurs. So if you look at the upper figures towards the leftmost first, takes around 4 days for emissions or for pollutants in the northeast of China to reach the Philippines. So it is first, it starts with a very high, very strong Siberian high. So the Siberian high is a high pressure system in Siberia. And because of this high pressure system, it creates a very stable environment in most parts of continental China. And then because of this stable environment, pollutant concentration accumulates. And then aside from creating a stable environment, it also creates a strong northerly flow. So as the pollutant accumulates, it pushes this pollutant southward. So if you look at March 6, for example, the pollutants are now in the East China Sea. If you look at March 7, the third plot, the pollutants are now in the subtropical region east of Taiwan. And then if you look at the March 8, it essentially the pollutants, they reach the northern part of the Philippines. So it takes around 4 days for this to happen. And this is cyclical, and that's the reason why we saw 2 high concentration events in the week-long period of measurement. Next slide, please. Yeah. So this is in the upper portion of in the upper portion, meaning aloft, around 3 kilometers high. There's also a different kind of transport that's happening. So what's happening is that there's a very strong westerly wind around 3 to 5 kilometers high. So this westerly wind essentially moves pollutants coming from the mainland Asian continent towards the Pacific Ocean. And what we're seeing is that emissions from as far as the Indochina region, they are being transported upward first, up to around 3 kilometers. And once they are aloft, they are transported eastward towards the Pacific Ocean. And this eastward transport actually transports emissions from the Indochina region. So next slide, please. So using the LiDAR measurements, we were able to see this layer of particulate matter aloft at around 3 kilometers. I encircled it with a red circle. And when there's a strong northerly wind, which essentially transports pollutants from northeast of China on the surface, this also comes up the 3 kilometer high layer of pollutants coming from the Indochina region. So essentially, these pollutants are biomass burning from the Indochina region. On the other hand, the pollutants coming from northeast China, they are mostly industrial anthropogenic emissions. Next slide, please. We also make use of the TCON data. I think the most notable thing to see here is the CO, sorry, the carbon monoxide at the lowermost plot. From around 90 parts per billion average during the high concentration event, it went up to around 150 parts per billion. So there's a 50 ppb increase in CO, which indicates that the pollutants are coming from biomass burning. So we presented this result in the paper in the remote sensing journal. Next slide, please. So we were able to develop a conceptual model of springtime flow for northern Philippines, wherein, again, on the surface, there's an increase, significant increase in pollutant concentration when there's a monsoon surge, winter monsoon surge. And these pollutants, they essentially come from the northeast of China. On the other hand, we also have long-range transport of pollutants from Indochina, but they are essentially all of them are aloft. Some of them are able to they're washed down essentially and are able to be measured on the ground, but not so much. It's mostly the East Asian pollutants that are dominating the measurements that we did in northern Philippines. So this is for the winter monsoon, or in Filipino we call it amihan. But especially during springtime, the flow is much stronger. After this study, there were several other studies that were able to show even during summer monsoon, some long-range transport mechanism can occur and transport pollutants from Southeast Asia towards the Philippines. Rainfall is a significant factor in transport. If there's more rainfall along the path of the transport, it diminishes essentially the amount of pollutants that are being transported. So some of the main questions that are usually asked is that what can we do with this long range transport? Because the discovery, I can say, the discovery of long range transport here in the Philippines is rather new. In fact, to our knowledge, this is our 2018 paper was the first paper to present long range transport here in the Philippines. So one of the main questions that how can we stop this transport? Essentially, the answer is there's nothing we can do because this is weather. And the thing we can do, just like in climate change talks, is that we urge the large emitters to do something about their emission. And even though there's transport that's happening here, still the local, especially in urban regions in the Philippines, we still have higher emissions compared to the ones that are being transported to us. So we should still focus on the local emissions, emissions being transported. Next slide, please. So the things that I presented here are from two papers actually. One published in 2018 in ACP, and the other one published in the Atmospheric Environment in 2020, if I remember correctly. So you can if you're interested in transport of towards the Philippines. Next slide, please. So to summarize, we have a TCON site in northern Philippines, the first in Southeast Asia, the first and only actually. So the TCON is primarily used for CO2 satellite validation. There are two CO2 satellites, the GOSAT and the OCO2. And every time these two satellites they pass the Philippines, they actually acquired site for targeting, so for validation purposes. There's long range transport of pollutants. However, the signal, or rather the amount of pollutants that are being transported here is not really that high. So we should still focus on local emissions here, I think. Uh, the the processes are very complex, so it requires more observations, more modeling, more understanding, essentially, of the not only of the emissions but the overall climate and weather here in the region. So that's it. Thank you for listening.
Thank you very much, Dr. Bagasa, for your presentation. We have a question from Mr. Kevin Cordovis of UPIESM. Does the movement of transboundary pollution a cause of concern with regards to air quality and health of the communities affected in the Philippines? Will the LGU
Go ahead. Sorry.
Will the LGU eventually need to issue seasonal alerts regarding this, similar to how China, Japan, Korea give seasonal alerts during Asian dust events?
Yeah, so like I mentioned, even though there's transport of pollutants, and this is for me not really concerning, since even with the large transport of pollutants, we are still within the national guidelines in terms of PM 2.5, for example. So it's not really a cause for concern. On the other hand, here in Metro Manila, for example, we usually experience very high pollutant concentration, and most people don't even think about it. So so no, it's not really a cause for concern, I think, for now at least.
Thank you, Dr. Bagdasa. Follow-up question, another question. So any chances of having another site, TCON site here in the Philippines?
It's difficult to put up TCON site because one, it's very expensive. Two, it requires a region wherein there's few cloud cover. And here in the Philippines, as you would know, there are many regions or many places wherein it's practically covered by clouds every day, most time of the year. So we were able to look for that site particularly. We're in around I think 7 to 8 months of the year. It's basically cloudless, and it's difficult to look for another site. So I don't think in the near future we'll be seeing another TCON site.
Thank you very much, Dr. Bagdasa. And
Thank you.
now to our last speaker, Nikki. Thank you.
Thank you, Erica and Dr. Bagdasa. So now we are down to our seventh and final speaker, which will be delivered by Dr. Jane Perez. Dr. Perez serves as a Deputy Director General for Space Science and Technology of the Philippine Space Agency. She is also an Associate Professor and Scientist too at UPIESM, and prior to her appointment at PhilSA, Dr. Perez has led various programs on satellite development in the Philippines, as well as other projects that utilize satellite and remotely sensed data for environmental applications and climate studies. She obtained her PhD in physics from UP Diliman and was a postdoctoral fellow at the NASA Goddard Space Flight Center. Her presentation is titled Satellite Data Products for Weather, Air Quality, and Atmospheric Processes in the Coming Decade. Dr. Perez, the screen is now yours.
Hi, Nikki. Thank you. So let me share my screen. Sorry. Oops. Sorry about that. Okay, can you see it now? Hello?
Yes, ma'am, we can see it.
Okay, you can see my screen?
Yes, ma'am.
So I am Jane Perez, and again, I thank you for coming to this webinar. So aside from the recent research related to air quality monitoring and advances in atmospheric processes, here I will present our plans for the utilization of satellite data products for weather, air quality, and atmospheric processes in the coming decade. So in my presentation, I will be introducing the Decadal Survey, which is an ongoing activity led by Stamina for Space Project 5 in coordination with the Philippine Space Agency. I will first discuss the Decadal Survey process, focusing on the weather, air quality, and atmospheric processes thematic area. In addition, I will be highlighting some accessible data and tools to help us in studying this field, specifically on the WMO's OSCAR and our local mirror hosted by ASTI to access satellite images such as Himawari, and also other ongoing opportunities with international partners such as the PAPGAPI project. So what is a decadal survey? Decadal surveys are community-driven, bottom-up studies that collectively identify key questions and observations to address our most fundamental problems. This process provides a rare opportunity for scientists and engineers to share their insights and help shape the scientific endeavors of the next decade. A decadal survey first assesses the current status of Earth observation needs and utilization in the country. Using this baseline, we define and prioritize the key challenges that could potentially be addressed in the next decade. With this assessment, it generates recommendations for an integrated and sustainable conduct of space-based Earth system science programs and technology applications. These recommendations should advance science and support a broad range of national economic and societal needs. Lastly, the decadal survey serves as a basis for determining the priority missions to address the most urgent and important questions, as we aim for a scientific approach towards giving highest priority funding to missions identified in the survey. From the survey, we are then able to list challenges and the corresponding objectives that are forecasted for the coming decade, which are also prioritized according to the importance or urgency. These corresponding objectives will serve as a guide to planning and building a roadmap for space, missions, and technology. So there are 4 focus areas identified for our decadal survey. These are hydrologic cycles and climate studies, Earth surface and interior dynamics and processes, aquatic ecosystems and water resources management, weather, air quality and atmospheric processes, hazards and disaster risk reduction and management, and terrestrial ecosystems and land resources management. For each focus area, the narrowing pyramid approach to prioritization will be applied to identify the most important objectives. So in phase 1, there are 28 responses from 28 experts, from which we extracted 54 challenges and 94 objectives. In the second phase, we aim to identify the most important objectives and determine priority clusters of objectives, which will be the basis of future mission and technology development. The decadal survey is a modular tool which can be conducted for other focus areas of interest. The findings of the decadal survey are objectives which we'll consider for data utilization and mobilization plan and our space technology roadmap. So this slide summarized the results from phase 1 per focus area, the shortlist of instruments based on gap analysis, and the initial space mission roadmap. So let's focus on number 2, which is weather, air quality, and atmospheric processes. For the second focus area, the gap identified was a high-resolution, multi-purpose imaging visible or to infrared radiometer. There are 8 challenges and 12 objectives that required this instrument. The initial space mission roadmap includes 4 proposed future missions. Based on development timeline of weather, satellite, and instruments, We hope that our very own weather satellite can be launched by 2030. This can change though, since in phase 2, we will still be reassessing the objectives, which can possibly affect the priority areas determined in the proposed missions. So the result of phase 1 of the decadal survey shows the current state of science in the country and what are the challenges we can address in the coming decade. For the weather, air quality, and atmospheric processes focus area, the challenges and science objectives are high-resolution climate change projection, short-term weather forecasting, air pollution and air quality monitoring, cloud masking, accurate atmospheric vertical profile, land, sea, air, human spheres dynamics, human activities and air quality interconnections, and long-range transport of pollutants. Based from phase 1 results of the decadal survey, the following are the geophysical observables that are needed to be studied in order to address the challenges identified earlier. So these include cloud top height, cloud size, cloud type and temperature, wind, precipitation, humidity, water vapor, atmospheric temperature, and aerosols and atmospheric gases. These geophysical observables with the existing satellites and instruments shown here. So white font indicates the name of the satellite and the cyan for the corresponding instrument. So we have Himawari and GOSAT-2 from Japan, the FY or the Fangyun satellites of China, Calypso from NASA and Kines, EarthCare of ESA and JAXA, and the NOAA JPSS satellites. So among the instruments investigated, it is the multi-purpose imaging visible to infrared radiometer instrument type that is seen to be the most applicable and versatile for weather and air quality applications. The instrument needed should have the capability to zoom in into the Philippines and acquire data more frequently than Himawari 8. This will allow higher resolution and higher revisit in the areas of interest. Should this capability be available to the Philippines, there will be a great improvement in weather observation and forecasting. So these are the ideal specifications of the high-resolution multi-purpose imaging radiometer with bands spanning from visible, near, SWIR, middle wave infrared, and thermal infrared wavelengths. A spatial resolution that is better than 500 meter, and full disk scan in less than 10 minutes, and with rapid scan function for the Philippines at 2.5 minutes or less. In the meantime, these are the resources we currently have. First is the WMO's Observing System Capability Analysis and Review, or OSCAR tool. So OSCAR is a free and online tool provided by the World Meteorological Organization. OSCAR can be used to find relevant instruments depending on the geophysical parameters to be observed. This tool can give you a list of instruments which provide related measurements along with with their operational lifetimes. So when you search an instrument, the information given are the following: instrument classification, mission and providing agency, the heritage missions, the primary and secondary objectives, instrument specifications, and access link where you can get the data. The database is also being updated regularly by focal persons from the WMO partner space agencies. So sorry about this, but this is supposed to show a screenshot of the WMO OSCAR tool, so you can see how to navigate the website. Sorry, it did not load properly. Okay, so it's here. I don't think it will play the video, but you may head to the space-based capabilities and do a quick search on aerosol. So from there, you can see results grouped into different categories. Okay, sorry about that. I'm not supposed to click that. Okay, let me go back to my presentation. Okay, From there, you can explore more and check which type of information you'd like to extract. So, as we all know, Himawari is one of the most advanced weather satellite we have now that covers the Philippines. We are lucky that we are included in the full disk scan and that we can readily access data from this satellite. Now we have faster access to near real-time satellite images from the Himawari 8 satellite through the DOST ASTI platform. So Japan's National Institute of Information and Communication Technology, or NICT, developed a web portal to access and view Himawari 8 satellite data in real time. DOST ASTI was selected to host a mirror website locally in the agency's servers through this web application called Himawari 8 Real-Time Web, where you can see the graphics of Asia-Oceania area from Himawari 8 displayed from visible cameras. The graphics are incremented with constant interval of 10 minutes over the Asia-Oceania area. Having this local web portal allows easier and faster access to weather satellite data, and retrieving said data will not have to go through several hops and pings around the world, since those in the Philippines will only need to access Himawari 8 data straight from the local mirror itself. However, if you want to acquire other bands of Himawari 8 for further processing, you can register for access of the full dataset using this site here. Okay, so upon registration, you will be granted an access to an FTP server, which contains the downloadable Himawari images. So in this site, you can also view near real-time Himawari images in 10 minutes resolution. So JAXA provides L1 products from Himawari in the following forms: sea surface temperature, aerosol optical thickness, shortwave radiation, chlorophyll A, wildfire, photovoltaic power, cloud optical thickness, and cloud type. So there are also users guide on these level 1 products that can be accessed from this site. So listed below are the following different potential areas using Himawari 8 data. So this includes severe weather monitoring, such as monitoring of thunderstorms, cloud development using brightness, temperature, cloud top height estimation, spatial and temporal variability of thunderstorms and its occurrences, tropical cyclone monitoring, tracking of its location, development, and its life cycle. We can also estimate rainfall amount or rainfall rate, which can be later calibrated by radar and ground stations. Other applications include urban and forest fire detection, and you can relate it to air pollution monitoring, aerosol concentration and migration studies, and observation of SST-related phenomena. So the Philippine Space Agency, or PhilSA, also have initiatives to derive such products from Himawari. Another highly utilized instrument for air quality monitoring is TROPOMI of the Copernicus program of the European Union on board Sentinel-5P. It is widely used for atmospheric chemistry studies, specifically to estimate concentration of various atmospheric gases and aerosols. So as shown, this is the extent of the Alpha volcano's eruption last year. So this is from TROPOMI's sulfur dioxide column data product, which you can access from the Earth Observatory, NASA's Earth Observatory website. So furthermore, through these institutions, the Philippines is now in a regional partnership with the United Nations Economic and Social Commissions for Asia and Pacific, or UNESCAP, and the South Korean National Institute of Environmental Research, NIER, for air quality monitoring. So this is a data sharing initiative. This data sharing initiative through the Pan-Asia Partnership for Geospatial Air Pollution Information, or PAPGAPI project, aims to fill in the data and information gap in nationwide monitoring of air quality, integrate satellite-derived data with reliable ground monitoring information for better understanding of air pollution, and improve model simulations of air quality, including its forecasting and warning service, enhance national and regional capacity to undertake the comprehensive analysis of data derived from space and ground networks, and promote policy dialogues and enhance the capacity for monitoring and management of air pollution. Now, the PhilSA is coordinating with UNSCAP and NIAR to move forward with this partnership. So this project involves the geostationary satellite validation of the GEMS payload on board the GeoCompSat-2B satellite of Korea. So through the Pandora Asia network, air quality all over Asia can be investigated using ground and satellite data. Specifically, there is an aim to install and operate the Pandora spectrometer instrument, integrate and validate GEMS data and reliable ground monitoring information for better understanding of air pollution and better utilizing air quality model for analysis, forecasting, and warning services. There is also a goal to set up at least one Pandora at area that is polluted and a background site in each Asian member country, including the Philippines. So in summary, overall, there are a lot of the identified challenges in the coming decade. Apart from these opportunities, we still need to maximize our access to Himawari 8 and in the near future, Himawari 9 and GEMS data products to strengthen our understanding of air and atmospheric processes. We hope to encourage more researchers to join us in our fields of weather, air quality, atmospheric researches. And so far, the decadal survey suggests that it will be beneficial for the country to have our own weather satellite by early 2030s. We hope this will bring in more opportunities and leapfrog the advancement of the field of weather, air quality, climate change, and atmospheric sciences, among others. So with that, thank you very much for your attention.
Thank you, Dr. Perez, for your presentation. Question, does ASTI mirror or directly download any other satellite data products aside from Himawari, or are there any upcoming plans in the pipeline?
Yes, so through the Pedro ground receiving station, ASTI is also downloading data from very high resolution satellites, so including ComSat of the Koreans. And also there is subscription from Planet and Novasar. So, but these are not usually not used for studying air quality and atmospheric processes. I think there's also a plan to mirror VIRS data in the future. But this facility, the Pedro facility, will soon be transitioned to the Philippine Space Agency. So all of these capabilities to directly download data or mirror data or subscribe data from these satellites and future satellites will now be managed and led by the Philippine Space Agency soon.
Thank you, Dr. Perez. Another question. For the PAP-GAPI project, when do you think will the public be able to access data from PAP-GAPI?
Yeah, so actually this year is the preparatory year where the MOA will be executed. The Pandora sensor will be installed, but hopefully towards the latter part of the year, like Q4, we hope to be getting initial data from this and make it available for our researchers who would be interested. I think this would run for another 2 or 3 years, so we'll see. But yeah, hopefully we'll start getting data before the end of this year.
Thank you very much, Dr. Perez.
So we now move on to the awarding of certificates. If there are no more questions, or if there are more questions, please feel free to email us so that we can address them later on, or we can forward them to the presenters.
Nikki, sorry for that. There are some questions for our speakers.
Oh, okay. Sorry, go ahead.
For Dr. Sentian, a question from Hasifa Aziz was raised. So aside from the Megan model, are there any other global models that can potentially be used to estimate biogenic emissions?
Right, Erica, thank you. For that particular questions, there is a few models that are actually being used depending on where you are, but the Megan is the most commonly used. There is another model, we call it BEIS, that is stand for Biogenic Emission Inventory System. I think that has been used in a number of studies in the USA. Yeah, that is also more or less they have some kind of similarity with Megan model. Yeah, so I'm not saying which one is better or which one is you should use or something like that. It's similar questions when you ask for climate model, because climate model also there's a number of climate models. So yes, to answer this, yes, there is another model to estimate the biogenic emissions that had been published or had been used. And come back to the related question, like any assessment on the accuracy of the Megan. Yes, I don't really call it accuracy in that sense, but there is evaluations of the result or assessment of the result from the model by, normally we evaluate the result from the model through either comparing with the similar model, but because they are using a different input for the same region, for example, in Southeast Asia. So there is, let's say there is a 2 or 3 or 4 researchers have been studied that one. So we compare, we evaluate our result with those previous model, because the differences is they might use different input on climate. They might use different input on the plant functional type, or even the left area index, or even the emission factor. So it's not the same. But in principle, we can evaluate how they are almost in the same train, or is it actually in the same range or whatever. So we can evaluate. It might not really appropriate if you call it accuracy, because none of the model that is really can claim that we are the most accurate one. So in modeling things, we don't really say it accurate. But yes, we did some kind of evaluations of the model.
Thank you, Dr.
Yeah, hopefully that's answer this question. Thank you.
Yes, Dr. Sentian, thank you very much. A question for Dr. Maylene Cayetano. Dr. Cayetano, during your weekday, weekend runs in the campus, did you observe some difference in the morning and afternoon black carbon concentration? And to what factors can you attribute this difference?
Okay, got it. Thank you, Erica, for throwing the question on behalf of the person. So we observed differences in the morning and afternoon levels of black carbon, and this can be attributed to the planetary boundary layer height. It was explicitly discussed by Dr. Makatangay, the trends in PBL height in the morning and in the afternoon, and how it varies within the day. And I also failed to show some graphs provided by Dr. Jerry Bagtasa, in which he did some modeling based on wharf output. So meteorological factors as well are affecting the ambient air air pollution, especially the levels of black carbon, wind speed in the morning and in the afternoon are quite different, and of course PBR height. So the impact on the morning pollution are more pronounced because of these meteorological differences. Thanks, back to you.
Thank you, Dr. Cayetano. Another question for you, Dr. Cayetano, from Mr. Conrad of UP Diliman. Do you plan on measuring the same parameters for less urban areas, generate a map for both urban and less urban areas for the whole Philippines, and make recommendations as to how to lessen the results of some of these parameters?
All right, thank you, Conrad. If you're talking about fingerprinting, the chemical components of particulate matter all over the Philippines, yes, that's the plan. So in fact, the ISM is currently in partnership with the DNR, Department of Environment and Natural Resources, Environmental Management Bureau, Central Office to do source apportionment studies in some of the regional offices, and also they are sending their reference method sampled particulate matter, PM10, PM2.5, and PSP, so that our research group can perform source apportionment studies. So any students interested to help us, we will be needing a lot of help on this because it's a big task that to benefit us all. Thank you.
Thank you, Dr. Cayetano. Question for Dr. Ronald Makatangay. Question is also from Mr. Conrad of UP Diliman. So having known to have conducted research across the world, in Germany, in Thailand, in the Philippines, have you tried comparing mixing heights of different biomes, say forest biome, tundra, taiga, or coastal areas?
Okay, so we also have, we're here in Thailand, we also have another LiDAR system near the coast. So in that site, we didn't see that much the clear, how you call it, the daily variation of the mixing height. I think mainly because in the coast, the temperature, let's say, doesn't vary. I mean, doesn't vary that much throughout the day. However, yeah, you can still see a bit of this daily variation. I think mainly because from the sea breeze, land breeze effect, since the mixing height also depends on the winds. So it's not as pronounced compared to the valley atmosphere that I showed in Chiang Mai.
Thank you, Dr. Makatangay. A follow-up question to that. So since most of us here are in Metro Manila, can you describe, or is there a difference between the behavior of the mixing height between Manila and Chiang Mai in Thailand?
Okay, so Chiang Mai is like a valley atmosphere. So we're surrounded by mountains up to, I think, 2 kilometer high. In Metro Manila, so one side, on the eastern side, you have the mountain, and then you have the coast on the western side. So it'd probably be something similar, but then you have a mega city in between. Yeah, so it would probably be affected breeze circulations, and then maybe near the mountains. Yeah, so I think it would be more like similar to a coastal site. But yeah, we really need the measurements to really be able to say something concrete about this.
Okay, thank you very much, Dr. Makatangay. For other questions for our speakers, you can send them to us and we will channel them to the speakers. So now we move on to the awarding of certificates for our speakers. Back to you, Nikki.
Thank you, Erica. So we would now like to virtually award the certificates to our speakers, signed by Dr. Maricor Soriano, signed by Dr. Justin Sentian, and Dr. Lemuel Aragones. So we award the certificate of appreciation to Dr. Maylene Cayetano. Virtual round of applause. And thank you, Dr. Cayetano. Next, please. We would like to award the certificate of appreciation to Dr. Justin Sentian. Again, another virtual round of applause. And we would like to award the certificate of appreciation to Dr. Nina Yulianti. Thank you, Dr. Yulianti, for your presentation. And we would like to award the certificate of appreciation to Dr. Ronald Makatangay.
Thank you.
Next, we would like to award the certificate of appreciation to Engineer Roseanne Ramos.
Thank you.
And then next, the certificate of appreciation is presented to Dr. Jerry Bagtasa.
Thank you.
And then last but not the least, we would like to present the certificate of appreciation to Dr. Gay Jane Perez.
Thanks.
So before we move on to the closing remarks, we would just like to do a quick virtual photo op. So if it's okay, we would like to ask all of the presenters to turn their video on. And then after the presenters, we will ask the participants to do the same. So now we would like to ask the presenters to please turn their videos on. And then Erica will be taking a screenshot.
Okay, so we have at least 5 pages for the participants. For the first page, 1, 2, 3. Okay. 1, 2, 3. One, two, three. 1, 2, 3. Okay, last. 1, 2, 3. All right, thank you.
Thank you, Erica. So now to officially close our program, we would like to call back Dr. Gay Jane Perez for the closing remarks.
Thank you, Nikki. So good morning once again. Thank you to our wonderful presenters and their comprehensive and insightful presentations. We hope that despite the constraints set by our current situation, we can continue to build and nurture our network, as Dr. Sentian, Dr. Soriano, and Dr. Aragones mentioned earlier. We know how important understanding and monitoring the chemistry of our troposphere is because of its possible health impacts being the layer of the troposphere nearest to us. We value the studies and research presented in this webinar and we hope to encourage more students and researchers to help us address gaps in our air quality monitoring and atmospheric dynamics, and ultimately help in improving the quality of air we breathe. On behalf of the Stamina for Space Project 5, I would like to thank our co-organizers, the Asia Pacific Network for Global Change Research, APN, and the Institute of Environmental Science and Meteorology for making this event possible. I would like to thank all our participants here on Zoom, as well as those tuning in to the live stream for joining us. We hope that you gained a lot of valuable takeaways from the series of talks. And I hope that someday, once it's safe enough, we can do this again and get together in person. So this officially ends our event, and I wish everyone a good day and stay safe and well.
Thank you.
Thank you, Dr.
Thank
Perez.
you.
Thank you to all our
very much.
presenters
Thank
and
you.
participants.
Thank you.
For those who will be requesting a certificate, so it's available upon request, but kindly bear with us and give us ample time to get back to you. So that concludes our event today. Thank you everyone again. Have a good day.
Thank you.
Thank you. Have a good day, everyone.
Thank you po.
Thank you, Erica, Nikki. all the organizers.
Thank you din, ma'am.
Thank you,
Salamat.
ma'am.
Good job.
Ingat
Thank you.
po. Take care.
Hi, Mai.
Yay! Dito na lang tayo.
Dito na lang tayo nagkikita. Hi, Sir Jerry. Andiyan ka pa. Sir Ron. Hello.
Hello, hello.
Thank you po.
So how many thank yous and bye-byes before we leave?
We're still live.
We still have 10 minutes.
We are still live.
Oh, yeah. Okay, sige na nga. Let's
Still have
do
10
it.
minutes.